keeping pace with AI, it feels like it's just accelerating, doesn't it? The power is uh, undeniable.
It really is.
But the real question, I think, is how we move beyond just, using it to actually understanding and managing it properly.
Exactly. And that's really the core of why we're doing this deep dive today.
Right.
We're kind of at this point where simply prompting a large language model, well, it's also not enough anymore for the really complex stuff.
Okay.
So the big shift, the really significant change we're seeing is towards AI agents.
Agents. Okay, define that a bit more. What makes an agent different?
Well, fundamentally, they're systems that are capable of autonomous action. They don't just respond, they act to achieve specific goals.
So it's that leap from passive processing to active doing.
That's it exactly.
Yeah.
And that's what we want to unpack today.
Okay, so AI that does things. Let's get into the mechanics then. What are the key parts that let them do that?
Think of it like this. You take the smarts of a language model, its decision-making ability, and you connect it to tools so it can interact with the outside world, or databases or APIs.
Right, give it arms and legs, so to speak.
Sort of. And then there's a crucial layer on top, the orchestration part, for reasoning, planning, deciding what to do next.
Got it. And the Agent's Companion white paper we're looking at today, that digs into this.
Oh yeah, it really gets into the nitty-gritty of all these components. It's quite detailed.
A blueprint almost for this next wave of AI. And look, this isn't just for developers coding this stuff, is it?
Absolutely not.
If you're just curious about where AI is heading, how these agents might change, well, everything. This is relevant.
Totally agree. Our goal today really is to pull out the most critical insights from this white paper.
Okay.
Specifically, how do we make sure these agents aren't just clever in a lab somewhere? How do we ensure they're effective, reliable, actually ready for real-world use?
Right. So the mission is lab to reality. How do we bridge that gap? Where does the white paper say we should start?
Well, one of the first kind of fundamental points is realizing that going from a cool agent idea, a prototype, to something dependable, something running in production, that's a huge leap. It's a major challenge.
Okay.
And this is where this new field, AgentOps, comes into play. It's becoming really critical.
AgentOps. Okay, I see the parallel. Like DevOps for software, MLOps for machine learning, now AgentOps for agents.
Exactly. It builds on those principles, definitely.
But what makes agents different? Why do they need their own ops discipline instead of just extending MLOps?
Good question. Agents have unique needs. For one, managing their tools, both internal functions and external APIs, is much more complex.
Okay.
Then there's the brain itself, the core prompt or instructions guiding the agent and how it orchestrates its actions. That needs careful management.
And memory. I imagine that's key if they're doing multi-step tasks.
It's absolutely vital. Maintaining context, remembering previous steps or conversations, and also breaking down big goals, task decomposition. These are all bigger deals for agents.
So they're not just processing data points. They're interacting, planning, remembering, acting over time.
Precisely. It's a different operational beast.
Okay, so we need AgentOps. How do we know if we're doing it right? How do we measure success?
Metrics. Metrics are absolutely foundational here. It's very similar to, say, A/B testing in web development or metrics-driven approaches generally.
Right.
You need to track things at different levels. High-level business stuff. Did the agent actually achieve its goal? Are users engaging with it?
The bottom line outcomes.
Yes. But also you need the more detailed agent-specific metrics. Things like latency, how fast is it? Error rates, how often does it mess up? Tool call failures.
So it's not just about if it works, but how well it works operationally, efficiently, reliably.
Exactly. Being smart isn't enough. It has to be practically useful and robust.
And what about the human side? Does user feedback still matter with these autonomous systems?
Oh, absolutely crucial. The white paper really emphasizes this. Things like user ratings, feedback forms, direct comments.
Why is that so important? Can't the metrics tell us enough?
Metrics tell you what happened, but often not why, especially from a user perspective. What looks okay on a dashboard might feel clunky or unhelpful to a real person.
Makes sense. The qualitative side.
Precisely. And for digging deeper when things do go wrong, the white paper talks about traces.
Traces, like breadcrumbs.
Exactly like that. Think of a trace as a detailed log, step by step, of everything the agent did, what it thought, which tools it called, what the results were.
Ah, like a flight recorder for the AI.
That's a great analogy.
Oh.
It lets you replay the agent's journey and see exactly where it went off track. essential for debugging complex agent behavior.
Okay, traces. Very cool. So we're operating them, measuring them with metrics and traces. But how do we evaluate the agent's fundamental quality, its actual capabilities?
Yeah, that's a key point the white paper makes. Evaluating an agent is different from, say, evaluating a generative model that just produces text or images. With agents, you're really focused on the decision-making process, not just the final output, the choices it makes along the way.
Right, because it's taking actions. Okay, so how does the white paper suggest we break down this evaluation?
It proposes a framework with three main components.
Okay, lay it out for us. How do we assess these things?
First, you need to assess the agent's basic capabilities.
Hmm.
Can it actually follow instructions accurately? Is its reasoning sound? Can it use its tools correctly?
The fundamentals.
Exactly. And this is where public benchmarks are useful. Things like Agent Bench for general skills, Plan Bench, which specifically tests planning.
Like standardized tests for AIs.
Pretty much. Agents DB Step Leaderboard is another example, focused on database tasks. Using these helps you get a baseline, see where an agent might struggle, identify potential pitfalls early.
So benchmark tests to find the inherent strengths and weaknesses. Got it. What's next?
Well, benchmarks are a good start, but they don't tell the whole story. The second critical piece is evaluating the agent's trajectory.
Trajectory. You mean the path it takes.
Yes, the sequence of actions the tool calls it makes, the whole step-by-step journey it takes to reach a goal.
Why is analyzing that journey so important? Isn't the final result what matters?
The final result matters, of course, but the trajectory tells you how it got there. Was it efficient? Did it take unnecessary steps? Did it make logical leaps or errors along the way?
Ah, okay. So you might get the right answer, but in a really convoluted or unreliable way.
Exactly. You compare the expected or ideal trajectory with what the agent actually did. The white paper lists some automated metrics for this, like exact match or in-order match for the steps.
So judging the quality of the journey, not just the destination.
Precisely. Now, a limitation here is that these metrics often need a predefined correct path, a ground truth to compare against.
Right, which might not always exist or be easy to create.
True. But the field is moving fast. We're starting to see the use of agent autorators.
Autorators. AI judging other AI.
Yes, using powerful LLMs to evaluate the quality of another agent's output, including its trajectory. It's an emerging area, but very promising.
Fascinating. Okay, so we have capabilities via benchmarks, the journey via trajectory analysis. What's the third piece?
The third piece is evaluating the final response or outcome. Simply put, did the agent actually achieve what it was supposed to?
Okay, the bottom line result.
Yes. And here, the white paper stresses defining your success criteria really clearly. What does good look like for this specific task?
Because success can be subjective.
Very much so. And again, autorators, LLMs acting as judges based on those criteria you define are proving really useful here for assessing the quality, relevance, and completeness of the final output.
Skills, method, outcome. Seems pretty comprehensive. But you mentioned subjectivity. I imagine automated tools can't catch everything. Is there still a role for humans?
Oh, absolutely essential. The white paper is clear on this. Automated evaluation gives you scale and quantitative data, but it struggles with nuance.
Like what specifically?
Things like creativity, common sense, contextual appropriateness, maybe the overall tone or helpfulness, subjective qualities.
Things that are hard to define in code.
Exactly. Human evaluators can pick up on that stuff. Plus, they provide really valuable qualitative insights, the why behind a problem that can guide improvements in ways automated metrics might miss.
And they can help tune the automated systems too, right? Calibrate them.
Precisely. It's a feedback loop.
Yeah.
Humans help improve the agents and the evaluation systems themselves.
So how do you practically incorporate this human evaluation? What methods does the white paper suggest?
Several ways. Direct assessment is one. Experts just rate the agent's performance on specific tasks.
Okay.
Comparative evaluation is another, comparing agent A versus agent B, or a new version against an old one, which one is better and why.
Side-by-side comparison.
Yes. And then there are user studies, getting real users to interact with the agent in realistic scenarios and gathering their feedback on the experience.
Right. Real-world testing. Makes perfect sense. Okay, let's shift focus a bit. The white paper also talks a lot about multi-agent systems. What's the basic idea there?
Yeah, this is a really exciting area. Think of it as moving from a single do-it-all agent to more like a team of specialized agents.
A team.
Exactly. Multiple AI agents working together, collaborated to tackle problems that might be too complex or broad for any single agent.
So specialization. Instead of one generalist AI, you have a crew of experts.
That's a great way to put it. Each agent might be optimized for a specific task, maybe even using different underlying models best suited for that job.
Interesting. What are the advantages of that approach? Why build a team instead of just a bigger, better single agent?
Several key benefits. You can often get higher accuracy because agents can double-check each other's work or bring different perspectives.
Okay.
Efficiency can improve too. Tasks can potentially run in parallel across different agents.
Makes sense.
They're generally better at handling really complex, multifaceted tasks by breaking them down. Plus, you can get better scalability, potentially better fault tolerance if one agent fails. Others might compensate and maybe even reduce bias by having diverse specialist agent.
Wow, okay. That sounds like a much more robust and potentially powerful way to handle complex challenges. What kind of roles do these specialized agents typically play in a team?
The white paper highlights a few common archetypes. You often see things like planner agents,
Their job is planning, obviously.
right, breaking down the high-level goal into steps. Then maybe retriever agents that are experts at finding relevant information.
Data gatherers.
Exactly. Execution agents that actually perform specific actions or use tools. And evaluator agents that might check the quality of work done by others or the final result.
It really does sound like structuring a project team with defined roles and responsibilities.
It's a very similar concept.
And the white paper mentioned different design patterns for how these agents interact. Can you walk us through a couple of those?
Sure. There are several common ways to orchestrate them. A sequential pattern is simple. Agent A does its thing, then passes the result to agent B, and so on.
Like an assembly line.
Pretty much. Then there's hierarchical, where you have a sort of manager agent coordinating multiple worker agents.
The boss agent.
Right. Collaborative patterns are where agents actively share information and work together more dynamically towards a common goal.
More like a brainstorming session.
Yeah. And there are even competitive patterns where agents might compete to find the best solution. Like in that overcooked AI example where agents have to coordinate cooking tasks under pressure.
Huh, competitive AI.
Yeah.
Okay, so when you're building these complex multi-agent systems, what are the key architectural pieces you need to consider?
It gets pretty involved. You need things like an interaction wrapper, basically, how agents talk to each other.
Communication protocol.
Exactly. Sophisticated memory management is crucial. Short-term, long-term, maybe even reflective memory, where agents can think about their own performance.
Metacognition for AI.
Kind of. Then there's cognitive functionality. Things like chain of thought reasoning applied across agents, robust tool integration, obviously, clear flow and routing, how tasks move between agents, feedback loops for learning and improvement, standardized communication protocols, especially if agents are distributed or need to work asynchronously. And importantly, agent and tool registries, like a directory or mesh, so agents can find the capabilities they need.
Wow, it really is like building a whole digital organization. Communication, skills directories, workflows.
It's a good analogy.
What are the big challenges in making all that work smoothly? It sounds incredibly complex.
It definitely is complex. Communication is the big one, ensuring agents understand each other correctly, task allocation, who does what efficiently. Coordinating their reasoning processes can be tricky.
Keeping everyone on the same page.
Right. Managing the overall context across all agents. And then there are practical things like, the time and cost involved running multiple agents can be more resource intensive. Just managing the overall system complexity is a challenge in itself.
Yeah, I can imagine debugging that must be fun. How do you evaluate if a team of agents is working well? Does it differ much from single agent evaluation?
The core principles, interestingly, stay pretty much the same. You still look at the overall success metrics. Did the system achieve the business goal? Task completion rates.
Okay.
Tracing becomes even more critical because you need to follow the interactions between agents to find bottlenecks or errors.
Makes sense.
And you still use trajectory evaluation and final response assessment. The main difference is that the trajectory now involves the actions and interactions of multiple agents. You're evaluating both the individual agent contributions and the overall system performance.
So analyzing individual performance and team synergy.
Exactly. And you start asking new questions unique to multi-agent systems.
Like what?
Like, how effective is the cooperation and coordination? Is the planning and task assignment working well? Is the system actually using the right agent for the right subtask, what they call agent utilization? And of course, how well does it scale if you add more agents or complexity?
Lots to consider there. Okay, moving on slightly. The white paper talks about Agentic RAG. Sounds fancy. How does that differ from the regular retrieval-augmented generation we've heard about?
Yeah, it's presented as a pretty significant step up. Traditional RAG is often more static. You do a retrieval step, find some documents, feed them to the LLM with a prompt, and get a response. One shot.
Retrieve, then generate. Simple enough.
Agentic RAG makes it dynamic. It uses autonomous retrieval agents.
Ah, the agents concept again.
Exactly. These
Sure.
agents don't just do one search. They can reason about the information need, formulate a query, look at the results, think about whether those results are good enough, and then potentially refine the query, search different sources, or break the question down and search again iteratively.
Whoa. So the AI is actively managing its own information gathering process, like a persistent researcher.
That's a great way to think about it. It allows for things like more context-aware query expansion, handling questions that require multiple steps of reasoning and retrieval, adaptively choosing the best knowledge sources, and even using other agents, perhaps, to validate or cross-check the retrieved info.
That sounds way more powerful for tackling complex questions where the answer isn't just sitting in one document.
It really is.
Yeah.
But the white paper also makes a really important point here.
Which is?
Even with cool agentic RAG capabilities, the quality of your underlying search and retrieval system is still absolutely fundamental. Garbage in, garbage out, agent or no agent.
Right. The foundations need to be solid.
Exactly. So optimizing things like how you parse and chunk your documents. It mentions Vertex AI layout parser and semantic chunking, adding good metadata, maybe fine-tuning your embedding models or using search adapters.
All the MLOps stuff for search.
Yes. Using fast vector databases like Vertex AI Vector Search, maybe adding a ranker model on top, implementing grounding checks to ensure the answer comes from the retrieved context. All that is still critical before you even get to the agentic layer.
Build a great search engine first, then make it agentic.
That's the gist. And it mentions tools like Vertex AI Search and the R engine as ways to help build and optimize those robust RAG pipelines more easily.
Got it. Okay, let's bring this back to the real world. How are these agents actually being used in businesses? According to the white paper, what roles are emerging?
It highlights two main categories emerging in the enterprise. First, you have assistants.
Like chatbots or virtual assistants.
Pretty much. Interactive agents that help users directly with tasks, answering questions, guiding them through processes.
User-facing help?
Right. The second category is automation agents. These work more behind the scenes.
How so?
They monitor systems, watch data streams, make intelligent decisions based on what they see, and automate processes without direct human interaction in the moment.
So one helps the user, the other runs the process.
Exactly. And the white paper suggests a potential future shift where knowledge workers become less about doing the tasks themselves and more like managers of agents.
Overseeing a team of AI workers.
Kind of. Assigning tasks, monitoring progress, orchestrating these digital helpers. It mentions Google Agentspace as a platform specifically designed for this, letting users create, manage, call upon, and orchestrate agents.
So control center for your personal or team AI agents. Interesting. It also mentioned Notebook LM Enterprise. What's that?
Yeah, that's positioned more as a research and learning tool. You upload your documents, reports, meeting notes, whatever, and the AI helps you synthesize the information, find connections, even generate audio summaries. It's about understanding your own information better.
Okay. And Google Agentspace Enterprise, how does that fit in?
That sounds like a more integrated company-wide solution. A unified search agent, maybe branded for the company, that provides conversational help, can make proactive suggestions, and accesses various company data sources, structured, unstructured, even with translation built in.
A company-wide AI assistant.
Essentially. And then Agentspace Enterprise Plus goes further, allowing companies to build custom AI agents tailored for specific business functions like HR, finance, customer support, connecting them to internal systems and external tools. It includes builder tools for development and management.
So, a progression from personal tools to company-wide assistants to fully custom integrated agents.
That seems to be the picture painted.
Okay, this next concept sounds really intriguing. Contract adhering agents. What's the problem this is trying to solve?
Well, the white paper kind of argues that our current way of telling agents what to do, giving them a goal, some instructions, a list of tools, maybe a few examples.
The standard setup.
Right. That might be okay for simpler tasks, but for really complex, high-stakes, mission-critical stuff, it might not be reliable or predictable enough.
Because there's too much ambiguity.
Exactly. The idea is to evolve towards agents that operate based on a much more formal contract to improve that reliability and task completion success.
Contracts for AI, like legal contracts.
It's an analogy, but yeah, think about the level of detail. These contracts would precisely define the desired outcomes, the deliverables, specific quality specs, even how success will be verified.
Much more explicit.
Yes. And crucially, it would include a process for negotiation and clarification upfront. The agent could ask questions if the task is underspecified, reducing ambiguity before it starts working.
Okay, that makes sense. Avoiding misunderstandings.
And for really big tasks, the contract framework would support generating subcontracts, breaking the work down into smaller contracted pieces.
Delegating, but formally. So what kind of information would be in one of these AI contracts?
The white paper suggests fields like a detailed task description, obviously, the specific deliverables, and their quality standards. The scope, including explicitly stating what's out of scope.
Important.
Very. Expected cost or resource usage, expected duration, what input sources the agent is allowed to use, and how it should report progress or ask for feedback.
Wow, that's thorough.
And importantly, fields for that negotiation part. Highlighting areas that are underspecified, maybe negotiating cost or timelines, pointing out potential risks, requesting additional inputs needed.
It really is like negotiating a statement of work with a human consultant or contractor.
Very much that kind of structured approach.
And what's the life cycle? Define, negotiate, execute.
Pretty much. Define the task clearly in the contract, negotiate to resolve ambiguities, and agree on terms. Then execute. And the white paper stresses that execution should prioritize quality and completeness, allowing the agent to iterate, self-validate against the contract specs.
Like the co-scientist study or AlphaCode examples mentioned.
Exactly, where systems showed iterative refinement and self-correction based on defined goals. The negotiation isn't just about cost either. It's about refining the specifications, the deliverables themselves. And feedback during the process helps catch issues early. Plus, that ability to break down big contracts into subcontracts is key for handling complexity.
This contract-adhering agents idea feels like a potential path towards much more trustworthy and dependable AI, especially for critical applications.
That seems to be the goal, yes. Building that trust through clarity and accountability.
Now, to make this more concrete, the white paper uses the automotive industry as a detailed example. Why is that a good case study for multi-agent systems?
Cars are interesting because they have this mix of needs. Some things need to run instantly, right on the device, for safety or core functions.
Like controlling the brakes.
Exactly. Other things benefit from cloud connectivity, traffic updates, streaming music, and there's a whole range of different tasks a driver might want help with. It's naturally suited to specialized agents.
So what kinds of agents are they putting in cars?
The examples include things like a conversational navigation agent, finding places, planning routes, suggesting points of interest along the way.
Makes sense.
A conversational media search agent, finding and playing music, podcasts, audiobooks. A message composition agent helping you draft and send texts or emails safely.
Hands-free communication.
Right. A car manual agent using RSD to answer questions about the car itself, like, how do I reset the tire pressure monitor?
That'd be useful.
Definitely. And a general knowledge agent for, random facts or weather updates.
Okay, a whole suite of specialized assistants. How do they work together? What are those interaction patterns you mentioned earlier, but in a car context?
Right, they illustrate several patterns. The hierarchical one is common. A central orchestrator agent listens to the user's request and figures out which specialist agent is best suited to handle it. Navigation, media, car info, etc.
The traffic cop directing requests.
Exactly. Then there's a diamond pattern. Here, the response from a specialist agent might go through another central agent, like a rephraser agent, before it reaches the user.
Why do that?
To ensure consistency in tone and style. Maybe the car manual agent gives a very technical answer, and the rephraser makes it more conversational and user-friendly. Or it could moderate for safety or appropriateness.
Quality control step for the language.
Precisely. Yeah. They give an example of turning a dry tire pressure loss detected message into a more helpful, looks like one of your tires might be low.
Got it. What else?
Peer-to-peer. This is interesting. Instead of a central orchestrator always routing, if an agent gets a request it can't handle, it might directly hand it off to another agent it thinks can.
Agents collaborating directly.
Yes. Could be more resilient if the central orchestrator has issues, or faster for some tasks.
Okay.
Collaborative pattern. This is where multiple agents might contribute to a single answer. Imagine asking, what's the safest way to handle aquaplaning?
Right. Complex question.
The car manual agent might talk about stability control features, a driving tips agent gives general advice, maybe the navigation agent knows about current road conditions. A response mixer agent then combines these pieces into one coherent answer.
Synthesizing expertise.
Exactly. And finally, the adaptive loop pattern. This is where an agent might try something, maybe check the results or ask for clarification, and then refine its approach.
Iterating towards the goal.
Right. The example is finding a specific type of restaurant, say vegan-friendly Italian nearby. If the first search fails, the agent might adapt, maybe broaden the search radius, then filter by reviews mentioning vegan, iterating until it finds a good match.
That adaptive approach sounds very useful for real-world messiness. So overall, what are the big wins for using multi-agent architectures in cars?
Specialization is key. Each agent does its job well, leading to potentially higher quality and more efficient responses. Performance improves because you match the right agent and maybe the right compute resource on device versus cloud to the task. Speed is crucial for some in-car functions, and dedicated on-device agents can deliver that. And there's natural resilience. If you lose internet connectivity, the essential on-device agents for navigation or car functions can keep working.
It really does sound like a well-designed team of virtual co-pilots.
Yeah.
Okay, almost wrapping up. The white paper mentions Google's agent building platform, Vertex AI Agent Builder. What's the pitch there?
It's positioned as Google Cloud's comprehensive end-to-end platform for building, deploying, and managing these kinds of sophisticated AI agents we've been discussing.
An integrated toolkit.
Exactly. It brings together several components. There's the Vertex AI Agent Engine, which provides the core runtime and streamlined development tools. Vertex AI Evil Service offers those evaluation capabilities we talked about, benchmarks, autorators, trace analysis.
The building blocks and the measurement tools.
Right. And then a portfolio of tools for the agents. Retrieval using Vertex AI Search or the RAG engine, accessing structured data via the Gen AI toolbox for databases, integrating with other applications, turning existing APIs into manageable tools using Apogee Hub, and of course, access to the latest LLMs like the Gemini family via Vertex AI Model Garden.
So everything from the core engine to the tools the agents use to the evaluation mechanisms all in one place on Google Cloud.
That's the idea. Leveraging Google's infrastructure, AI research from DeepMind, and incorporating those AgentOps best practices to make building and deploying these agents more efficient and secure.
Well, this has been incredibly insightful, a real deep dive into where things are heading with AI agents based on this Agents Companion white paper. It definitely feels like we're on the cusp of a major shift.
I think so too. It's not just incremental improvements anymore. This move towards agentic AI, AI that can act and interact and plan. It really does feel like a fundamental change with huge implications.
Yeah, across pretty much every industry you can imagine. For me, some of the really powerful takeaways were that structured AgentOps approach thinking operationally from day one.
Crucial.
The different layers of evaluation capabilities, trajectory, outcome, plus the human loop, that feels really necessary.
It is multifaceted, yeah.
The sheer potential of multi-agent collaboration for complex problems. Agentic RM making information retrieval so much smarter. And seeing those concrete examples, like in cars or the enterprise tools, it makes it feel very real.
Absolutely. And maybe for you listening to this, the question becomes, how could these principles, AgentOps discipline, multi-agent designs, contract-based clarity, how could they apply to the complex challenges in your own field or work?
Ooh, that's a good question to leave people with.
What new possibilities open up when you think about breaking tasks down and having specialized AI collaborators work on them?
A really provocative thought. I definitely encourage everyone listening to explore these concepts more. Check out the resources if you can. This space is moving incredibly fast.
It really is. The evolution of AI agents is ongoing, and their potential to transform how we work, how we learn, how we interact with technology. It's vast. It's going to be quite a journey to watch.